Entonces, so welcome everyone to this session of the LACEAN LAMES conference. We are in session named Economics of Crime 3. It's a pleasure to be here today, so I thank the rest of the panel and the participants in this session. First up, we have a paper by Mateo Velázquez Giraldo from Johns Hopkins University. We will have around 25 minutes per paper, plus some time for Q&A. And that's it. Please do not interrupt the speaker in the first 5 minutes or so he can actually go through the explanation of the paper. Mateo, the floor is all yours.
Thank you so much, Magdalena, and I'm very happy to be here today. Thank you all for coming. This is I'm very excited to be presenting this work, which is different to the stuff that I do nowadays. I'm more in the household finance field this year, but this is work that I started in my master's, and we're trying to work on it, and so we're looking forward to your comments and your questions. I think I'll be very brief, so feel free to interrupt me if you'd like. But with that, let me tell you about crime variability, peer effects, and economic inequality in social networks. So the motivation for this paper comes from the well-known fact that social interactions can not only influence individual criminal decisions, but also they make aggregate criminal patterns more variable. In the sense that if one of my friends being a criminal makes me, in some sense, influences me to also be a criminal, that makes crime harder to explain. But then what we want to ask with this paper is, well, how exactly are the potential criminal participation patterns of a community shaped by social links and by the economic inequality that is present in that community? What we find is, well, we build a theoretical model of social crime participation, and we simulate it. And through our simulations, we find that social networks that are denser in the sense that they're more tightly linked, or in which social links are more unevenly spread, so there's inequality of connectedness, in those communities, crime will be more variable in the sense that the criminal patterns that will emerge in equilibrium will be more polarized. Also, wage equality in the sense of the wage distribution being flat also is conducive to more crime variability. We also find an interesting effect in the average equilibrium crime rate. We find that as wage inequality goes up, there's a hump-shaped effect on the average equilibrium crime rate. So that's a brief summary of the paper. Now let me give you some context and mention some related literature. We begin with the fact that crime has a very high unexplained variance. This in the sense that if you take two communities that have very similar observable characteristics, you will often find that they might host very different criminal patterns, and we're not sure why. So that's the high unexplained variance. One good explanation of it was posed by Glaser, Sacerdote, and Scheikman, who they said, well, if there's social interdependence to criminal decisions, that is a potential cause. If my friend being a criminal makes me likelier to become a criminal, and the econometrician or the economist does not observe that influence or doesn't know why my friend became a criminal in the first place, then that's going to show up as unexplained variance. Then this argument was taken to a more formal model by a paper by Caldwell, Mignol, and Zeno. They build a theoretical model of crime in the social network, and in their model, they come up with two sources of unexplained variation. First, take a community, live its observed characteristics constant, but if you change the way in which individuals are socially linked in that community, you will find that criminal patterns will change. Also, even if you leave both the observable characteristics and the social structure constant, in their paper, in their model, crime is a phenomenon with multiple equilibria, and we just don't know what equilibrium will be played, and that's again a source of unexplained variation. So after that, there has a very productive vein of the literature that has specialized this model, and it has mostly been focused in settings in which criminals decide how much effort to exert, but they're always criminals, and also they're specialized so that there's a unique equilibrium of criminal effort. there have been major developments, and has been a very, very fruitful literature. We will see one of the papers later today, but they have been even able to take it to policy recommendations that have received empirical validations, which has been massively useful. But still, we think that even if there's this very useful branch, there's another branch that could be explored or better understood. In particular, this kind of models leave out things like criminal prevention. So criminals are always criminals, and they have no like outside option. And also, since you're specializing the models where there's a unique equilibrium, you're leaving out a great part of the crime variability puzzle in this multiple equilibrium channel that I just mentioned. So what we do in this paper is, well, let's study the decision of whether or not to become a criminal, and let's try to keep track of all the possible equilibria that may arise in our model, and see how that equilibrium set looks. How does it change, and what kind of criminal patterns it can house. So let me now tell you about the model. It's a very simple model. It's inspired in the criminological theory of differential association. If you want to get into that later, we can. For now, let me just describe the formal parts of the model. There's n players, and they are connected to a social network that we denote with its connectivity matrix as its standard. They simultaneously decide whether to engage in crime or not. And that's the only decision that they take. The payoffs, well, if they decide to work lawfully or not engage in crime, they will just receive their formal wage. And if they decide to engage in crime, they will get also a payoff from crime that it's made up of two components. The first one is the net expected proceeds from crime. The second one is just a monetized psychological component of the payoff from committing a crime. So let me tell you a bit more about those payoffs. Well, wages, we just assume that are exogenous and idiosyncratic, so they're heterogeneous. The expected net monetary payoff from crime, we assume that it's an individual specific function that is increasing in the number of your friends that are criminals. So if I have 5, 6, 7 friends that are criminals, my payoff from crime will go up. There's a complementarity in the monetary payoffs from crime. And then the psychological component, we assume that it's also an individual specific function, but the restriction that we impose is that it's increasing in the fraction of your friends who are criminals. So what this wants to say is, if all of my friends are criminals, then I will have positive attitudes towards crime, so I will derive a payoff from committing a crime. While if I'm the only criminal in my social network, I will feel some maybe stigma and will get negative payoffs from committing a crime. So that's the whole model. And in this very general form, the nice thing is that it turns out to be a supermodular game. And supermodular games are just a formalization of games in which agents' actions are complementary. In this model, if I become a criminal, then my friends, their incentives to become criminals also increase. And so that's why it turns out to be a supermodular game. This is a very, very convenient theoretical property. And we explored that in the paper and derived some nice results. But for now, let me just tell you that this property guarantees that there's the equilibrium set is not empty, but also it's partially ordered. So we can find all possible equilibria, and they're always kind of ranked. And there's an equilibrium with the least amount of crime and an equilibrium with the greatest amount of crime. Another nice property is that these models have monotone comparative statics. So we know kind of the direction of the effect that on the equilibrium set that different shifts in parameters will have. So for instance, any positive shift on any component of the criminal payoff of any agent will have non-negative effects on the minimum and maximum crime rates. And any positive shift in the wage of any agent will have a non-positive effect on the minimum and maximum crime rate. So the equilibrium set kind of shifts up or down according to these parameters. So modularity is also nice in that it allows us to find all the equilibria efficiently, and there are many, and so that's what allows us to conduct the simulation exercises that I'm going to show you. So now let me tell you about those exercises. the goal here is link environmental properties of the model with the equilibrium set, as I just told you. So, for instance, we're going to vary a characteristic of interest, which is, for instance, the network's density or connectedness, or the wage variability in the wage distribution. And we're going to run simulations. So we're going to simulate both a network and a set of agents payoff. For each simulation, we're going to find all the Nash equilibria of the game and store the minimum, mean, maximum, and standard deviation of equilibrium prime rates. And then we're just going to plot the relationship between this characteristic of interest and the various summary statistics of the equilibrium set, just to get a sense of, what does the equilibrium set look like when we change these characteristics. So in order to simulate the model, the previous theoretical results are kind of free of the calibration, but in order to simulate it, we do have to calibrate. The wage distribution, we just assume that it's log normal with mean 1. Criminal productivity, as I told, is going to be heterogeneous. It's easier to represent with the pictures. I'm showing it to you here. Shaded areas are 95% kind of confidence intervals, and the solid lines are the averages. In blue, I'm showing you the wages, and in gray, I'm showing you different components of the payoffs from crime. So net monetary payoffs from crime, I'm assuming, are kind of increasing in number of criminal peers. And as you can see, on average, for an individual with 6 criminal friends, is going to be around 3 times the average wage, but it can go up to 8 times the average lawful wage. We roughly try to match the numbers from Levitt's Gang's paper. Then the psychological component is much harder to get kind of estimates of that. So we just assume, if all your friends are criminal, you're going to get a positive payoff equal to the average lawful wage. And if none of your friends are criminal, then you're going to get negative that. And in total, the utility from crime ends up being this function on the right-hand side, and it has substantial overlap with the wage distribution. So let me tell you about the first experiment. And so we're going to focus in the first two on characteristics of the network. The first characteristic is how dense the network is. So we're going to simulate networks with 20 agents, and we're going to use this model that's called Poisson random networks. And this model has a parameter that's P, which is the probability that any combinations between 2 agents is linked. So you will find that when P is very low, we have networks that are kind of not very dense. But as you increase it, you end up with networks that are very connected. So pretty much everybody is connected with every other agent. So again, P is driving how dense or how tightly connected the network is. So here I'm showing you again on the x-axis is this P parameter. And I'm showing you how different characteristics of the equilibrium set change with that parameter. First, the number of equilibria decrease. What's going on here is initially when the network is very sparsely linked, then social complementarities can lead you to many different places. And notice that there's a lot of equilibria just for 20 agents. But as the network becomes more and more connected, social complementarities become very strong, and you end up converging to places where everybody is a criminal or nobody is. Since criminal activities are complementary, if everybody is linked, and there's always going to be an equilibrium in which everybody is a criminal, and the minimum crime rate might even shift up, because you might draw somebody who's going to be a criminal no matter what, and he's going to propagate all those complementarities through the network. So that's why the standard deviation of equilibrium crime rates increases, right? We're tending towards a setting in which the only kind of true equilibria is the whole network is a great crime gang, or nobody's a criminal. And that's maximum variability. So social complementarities or density in social connections kind of polarize the possible equilibria that arise in this model. Then the next exercise that we want to look at is, okay, hold the density of the network and the total number of links kind of fixed, but how you spread those links around, what effect does that have in the equilibrium? For that, we use this model that's called preferential attachment networks. And I don't want to go into details, but there's this alpha parameter that basically drives how unevenly links are distributed in this model. So for this, I'm showing you pictures here. So when alpha is equals to 0, you can see on the left that I have a network in which, most agents have kind of the same, roughly the same number of links with a little bit of variability. But as alpha starts increasing, you start to get to networks in which, a handful of agents hold most of the links. So these are agents with very great kind of influence in the network. So again, alpha is shifting how concentrated is the constant number of links in this network. So again, the same idea with these pictures. I'm varying alpha on the x-axis, and I'm showing you each dot is a simulation, and in blue I have like the non-parametric mean estimator. So the number of equilibria again is decreasing. What's going on here is that as I increase alpha, I'm making the social complementarities rely on a smaller and smaller number of individuals. So the actions of those individuals that are fewer is going to be what matters for the equilibrium prime rates. And that's why the number of equilibria decrease. Minimum, maximum, and mean prime rates, there's not much action, but the standard deviation of prime rates in equilibrium does go up. Again, why? Because, if I'm the central person in the network and everybody's connected to me, I have two decisions. I can either become a criminal or not. And I'm going to drive these big sections of the network into crime or out of crime. And that's again, this convergence to polarization of this complementary action is what's driving a higher crime variability in the potential crime patterns of the network. The final exercise that I'm going to show you today is we want to show how wage inequality kind of shapes the equilibrium set. Again, remember that we assume that wages are log normal, but what I'm going to do is that I'm going to apply mean preserving spreads to that distribution. So I have this parameter eta that multiplies the variance of the normal that's exponentiated, but I'm going to adjust the mean so that it's kept constant. So I'm again applying mean preserving spreads to the wealth distribution. I'm going to simulate networks and draw. So keeping the networks constant, I'm going to draw wage distributions with different variances, and again just plot the characteristics of the equilibrium sets against this amplification of variance that I just told you about. So here I changed the format because there are a lot more simulations. So the dots are the average, and then the shaded regions are regions that contain either 90% or 70% of all the simulations. Again, as wage variability increases, the number of equilibria go down substantially. Why? Well, because if we are all very concentrated, then social complementarities matter a lot, right? And so that number of equilibria gets very high. But if the wage distribution is completely unequal, then what ends up mattering for what I choose to do is my wage. If it's low enough, then no matter how many criminal peers I have, I'm going to be a criminal. And so this enhanced importance of wages as they become more dispersed is what drives down the number of equilibria. Then the maximum crime rate goes down as variability increases. What's going on here is that as I draw agents with higher and higher wages, those are going to never become criminals, and they are going to disrupt the complementarities of crime spreading through the network. The minimum crime rate, however, has an interesting pattern, which it initially goes up and then down. What's going on here is that as I apply a little bit of inequality, then I'm driving some people below their lawful wage, and they're starting to go into crime and influence others and increase the minimum crime rate. But then as the wage distribution gets sufficiently spread out, these individuals who are never criminals are going to stop that social spread of crime. These two kind of forces combine into this mean crime rate pattern that, as wage inequality initially goes up, the mean crime rate also increases, but then it starts declining. We have to explore this a bit more, but it's been surprisingly robust. But what is definitely true is that the standard deviation of crime rates in equilibrium does go down with wage inequality. Again, because things are becoming more deterministic in the sense of depending more just on the wage that I draw. I don't care that much about my friends if my wage is 0 or very high. I just take the decision that's determined by my wage. So those are the experiments that I wanted to kind of show you today. So let me just recap. We've constructed a social model of crime as a supermodular game. It's inspired on the criminological theory of differential association. It has multiple equilibria, and this contributes to crime variability. We have conducted some experiments to analyze the effects of different environmental characteristics on the equilibrium set. We found that link density reduces the number of equilibria, increases variability, and has a positive effect on the average equilibrium crime rate. Having networks in which social links are more concentrated also reduces the number of equilibria and increases variability. And wage inequality has an interesting effect in which it lowers the number of equilibria, it reduces variability, but it has a hump-shaped effect on the mean crime rate. What we would like to do in the future is to try and study potential policy rules, as in the key player literature. It's kind of hard with this multiple equilibria, but maybe. And also try to find proofs of the relationships that we have found through simulations. That's what I had for today, and thank you very much for having me.
Well, thank you, Mateo, for your presentation. Now we will move into Camilo's presentation that is up next, but please stay tuned for the session so we can ask Mateo some questions after we finish with the presentations of this session. So now, as I was saying, we have Camilo Cepeda Plantese for his presentation. If you could share your screen, Camilo.
Yes, thank you, Magdalena. I'm going to share my screen. Can everyone see it?
No. Now, yes.
Yes, okay.
Now we can.
Full screen. Okay. Good morning, ladies and gentlemen. I'm going to present the research paper that we have been doing with Professor Aurora Ramirez at the Colegio de México. Well, we decided to study the effects of the judicial reform in Mexico. This reform was part of a wave of reform that swept Latin America in the early 1990s, and it intended to replace the old inquisitorial system with a more, let's say, modern American-style adversarial one. It was expected that this change would solve many of the problems that the old inquisitorial system had, like human rights abuses and a slow and cumbersome judicial process. But due to the security crisis affecting the region, there has been increasing call to reverse many of the chains of these reforms, especially those strengthening human rights protections of the accused. So, therefore, we think it's now more important than ever to examine the evidence regarding the change introduced by the reform and the effects that those changes had to better evaluate the real effects of reform and how to adapt it to the security crisis that the region is facing. Okay, so we use the quasi-experimental nature of the staggered rollout process of the reform and a variety of municipal level administrative data to identify the effect of the reform on the homicide rate, the use of pretrial detention, and the celerity of punishment in the municipalities that adopted the reform before 2012. We chose those variables because we wanted to measure the effect on a crime rate, and well, due to data limitation, we can only measure it on the homicide rate because there are not many municipal level data for the whole country. We chose to study the use of pretrial detention because one of the greatest problems in the old Mexican system was the overuse of pretrial detention, even for non-violent crime. For example, stealing something on a supermarket, these criminals could end up for 3 years on pretrial detention, and at the end get a sentence of 6 months or something like that. And also we chose to study the impact on the celerity of justice because it's one of the most the most widespread critiques of the system in Mexico and in Latin America. So our research questions are the following. Was there an increase in the municipal homicide rate associated with the reform? How this effect interact with the presence of organized crime? Was there a reduction in the use of pretrial detention? Was this effect specific to some types of crime? And was there an effect on celerity and justice? And we also measure the specificity of this effect. And here we can see a map of the municipalities that adopted the reform before 2012. And as we can see, this is a fairly heterogeneous group. We have municipalities from the north, the south, the center. Oh, well. What were the changes introduced by the reform? Well, the first one is a more clear separation of the function of the prosecution and the sentencing judge. Under the old system, the judge and the sentencing judge and the prosecutor collaborated or worked together during the investigation. And this could and often did create a conflict of interest because the sentencing judge wasn't an impartial part. He was already invested in the investigation. The reform also introduced oral and public trials, and the goal of introducing those trials was to bring greater transparency, but also to make the system more fast, because under the old system, the whole process was based on written documents, and this made for a very slow and cumbersome process. It also introduced alternative dispute resolution and plea bargaining to avoid full trials. And this change was introduced also to make the system more efficient, to have faster sentences, and also to use the resources of the justice system more efficient. It also banned the use of confessions as evidence if not obtained in the presence of the defense attorney. And this change was introduced because under the old system, many guilty pleas were obtained under torture. And there are many studies of this. Well, this is a change for a greater protection to the human rights of the accused. It also gave a greater intervention to the defense during the investigation. And it also introduced a due process judge separated from the prosecution and also the sentencing judge in charge of protecting the rights of the accused in every procedural stage. And it also placed greater limitation on the use of pretrial detention. So the effects on the use of pretrial detention and the celebrity of justice are fairly straightforward, because the system places a codified limitation on the use of those things, but the effect on crime rates is less straightforward. Okay, so we're going to consider three main factors that come from the classic model of Garibek, and those are the probability of punishment, the severity of punishment, and the celerity of justice, or the celerity of the punishment. Well, the greater due process protection could make it harder, and should make it harder to obtain guilty sentences. So we will expect that the reform, those changes that increase the due process protection, should have a positive effect on crime rates. Plea deals and alternative conflict resolutions often trade a guilty plea for reductions in punishments. This also could have an incremental effect on criminality by reducing the severity of the punishments. And punishment that are closer in time are subjectively greater for a time discounting criminal. So we would expect that faster judicial processes should increase the subjective value of the punishment, and therefore have a reductive effect on crime rates. And we also consider two other factors. The first one is incapacitation, and we would expect that if we make it harder for the prosecution to obtain pretrial detention, that many criminals that would under the old system be under pretrial detention, well, they would be on the streets and they could commit more crimes. And last but not least, the legitimacy. If the general population trusts the criminal justice systems, we would expect for them to be more cooperative with it, and therefore making it more efficient. So we would expect that greater due process protection could enhance the trust of the system and therefore reduce crime. So as we can see, the reform introduced many changes, and we cannot a priori say what the sign of defect would be. Well, we use many municipal level data, but our main data set is estadísticas judiciales en materia penal, and this is a data set composed of administrative records at a case level of the persons under prosecution or sentences in criminal courts of first instance. Well, and along many other data, I'm going to skip this because for the sake of the time. So what are the methodological issues of our investigation? Well, the first one is because of the non-random nature of the adoption of the reform, there is significant heterogeneity between those that adopted the reform and those that did not. So we would expect that the pre-treatment parallel trends assumptions to be unlikely to hold under these circumstances, especially because we're working with thousands of municipalities. And also, and this is an important methodological problem, is that the implementation of the reform coincides with the beginning of the drug war in Mexico. The first municipality that introduced this reform was in 2007, and the drug war began in the very same year. Calderón began his war in December of 2006, if I remember correctly, and therefore it's fairly difficult to disentangle the effect of the drug war and the effect that the reform could have had. So to solve those issues, we adopted generalized synthetic control, and this is a technique that is close in spirit to that of Abadi, but it's statistically, or the model, the econometric model, is closer to a two-way if and if. But instead of having only fixed effect, this model introduced factors. And what are factors? Well, factors are interactions between common time-dependent trends that have differential effects at the unit level. Okay, so this is a way to solve the problem of the non-parallel pre-treatment assumption of the diff and diff model. Well, I'm going to skip this for the sake of the time. Okay, so we're going to begin discussing the results, and we observe a positive effect on the municipal homicide rate associated with the reform of 4 victims, more victims per 100,000 inhabitants. However, this effect seems to be specific to the municipalities that have an established presence of cartels before the reform. To test this, we estimated the effect on two subsamples. A first one composed of municipalities that had no cartel premises before 2006, and a second one composed of cartels that had one or more cartels in 2006. This is okay. This is the graph of the treatment, the average homicide rate for the treated municipalities here in the black line, and the blue dotted line is our estimated counterfactual. As we can see, the fit is okay before for the pre-treatment period. And on the left, we can see the estimated average treatment effect. Here we can see also the dynamics of the effect. As we can see, the treatment effect is 0 for all pre-treatment periods, except for the year before the introduction of the reform, but the sign here in year 0, we can see, is counter to the cumulative effect. And as we can see also, the effect only began to be positive from the third year on. So we can see that there was probably a learning period before this procedural change had an effect on crime rates. So I was saying that...
You just have 5 minutes left.
Okay. Okay, so so we said that this effect was nonetheless specific to those municipalities that had prior established organized crime presence, and for this we estimated the effect on two subsamples, and as we can see, the effect on the group that had no cartel presence, the effect is no longer significant, and for the group that had an established organized crime presence, well, the effect is both quantitatively big and very significant. So these tell us that even though the reform could have an incremental effect on crime rates, the effect is not generalized, and there is an important interaction between organized crime and the procedural changes of the reform. Okay, and now the use of pretrial detention. We observe a reduction of 8% in the use of pretrial detention for all crime, and we observed that this reduction was greater for property crime. It was of 16%, and for rape, it was also 7%. And this reduction was not significant for homicide and kidnapping. So this tells us also that the effect was also specific to some sort of crime, and I would say that those crimes are those that had that are either not especially violent, like property crimes, or crimes that are especially difficult to prosecute, like rape and sexual crimes in general. So here we can see our estimated effects for different categories of crime. Here we can see the fit of the model and the estimated ATP. And we did The same for the celerity of punishments. And here we didn't observe a significant general effect, although there seems to be a significant effect from the second, third, and 6th years on of the reform, but not a general effect for the whole period. And regarding the analysis by type of crime, we observed that the reduction was only significant for property crimes, and we observed a reduction of 58 days in the time elapsed between the commission of the crime and the sentence. Okay. The results. Okay. Okay. So now to finish, we observe an increase in the homicide rate due to the reform, but this effect seems to be specific to the municipalities that had previous organized crime presence. There was a general reduction in the use of pretrial detention. This effect seems to be specific also to certain types of crime. It was not significant for homicides and kidnapping, and significant for property crime and rape. The effect on celerity was only significant for property crimes, and the reform seems, and to sum it up, and this would be my policy recommendation, the reform seems to have helped solve some of the human rights issues prevalent in the old system, especially the overuse of pretrial detention. And the negative effects of its reform, those concerning the increase in the homicide rate, seems to be associated to the interaction between the reform and organized crime. So therefore, any change proposed to the criminal justice reform, we think should take this specificity into account. Okay, thank you very much. Yeah, thank you.
Thank you, Camila, for your presentation, perfectly on time. So now let's move to the last paper of the session, which is mine. But once again, please keep your comments for Camila so we don't miss them at the end of the session. So I will now share my screen. And I will be keeping time, but just in case if I'm being too much over, please let me know. So to wrap up this session that I think it's quite well connected one paper to the other, I will be presenting you this paper that was my job market paper last year. It refers about how it refers to the effects of tough on crime policies as sweeps might be, and the effect that they have on the criminality of gangs, taking some sort of network approach for it. So what we know in some terms of the motivation for this paper is we know that crime is actually quite worrisome and that it affects well-being at an individual level, but also in a society. For instance, in terms of the European Union, that is not one of the settings in which this paper will be embedded. We see that around 12% of the population reported crime in the area where they live. This is even higher in urban than in rural areas. And if we can take a look at the values for Latin America, this value is even higher, but with high, let's also say with larger heterogeneity across countries and across regions. In this, moreover, in terms of the economics of crime, we have this pioneer model by Becker, which actually was setting the ground for the field, framing crime as a rational act, which it has its costs and benefits. And one of the, let's say, more used conclusions in this sense is that individuals might turn to crime or might decide to commit a crime if the benefits of doing so are higher than their costs. However, one feature, even if this is quite of the, let's say, milestone of the economics of crime and a paper that we have been following for quite some time, there are some features that this model doesn't explain broadly. So for instance, there are some factors or some stylized facts that we see nowadays about crime that are not explained by the model. And for instance, some of the causes that have been said for this is that it doesn't account for the social interactions, for instance, as Mateo was saying at the beginning of his presentation as well. And in this setting, the literature on peer effects and which are the effects of social interactions on crime have been widely studied throughout the literature and this estimation on the peer effects. And the last point that I will make to motivate this paper is the fact that in order to deter crime, there's still some considerable debate over which are the types of policies to follow. So how should we deter crime? On one side, we have a set of policies that are mostly based on this tough on crime approach with strong police, seizures, etc., etc. And on the other side, we have some sort of the policies that are sometimes labeled as soft, that are based on reducing crime triggering disparities. So community-based interventions, education, etc., these types of approaches. So when we have this in mind, what I want to do with this paper is I will study the deployment of gang sweeps and I will see which is the impact that they have on the criminal activity of the individuals that were arrested in the sweeps, as well as of their criminal peers. Concretely, the research question that this paper will try to follow or to address is to see if sweeps are successful at reducing the crimes of the individuals that are arrested in the sweeps. Then I will also try to see if they diminish the crimes of the peers that were not arrested themselves on the sweeps. And lastly, as some sort of policy exercise, I will try to analyze if a network analysis and the knowledge of the network itself can provide a better design in terms of policies, particularly in the case of sweeps. And throughout this presentation, the empirical setting in which I will be focusing is on the metropolitan area of Barcelona for different reasons. The first one is the relevance of this setting. Barcelona is a city that has 4 million inhabitants. It is the 5th largest and the most dense metropolitan area in Europe. It's also a setting in which has high crime rates for the European context. Here I'm showing you some numbers, but it's only behind Paris or Amsterdam, for instance, when we take a look at criminal patterns. So it's actually something that is quite salient in society. And lastly, that the global victimization index of this area has been on the rise. Lastly, in terms of opportunity, I gain access to some restricted administrative data sets from the local police that has all the registries for a 6-year period between 2008 and 2014 about every arrest that they do. Overall, it has around 1.5 million entries. In this, I have information on the date, the time, the place, and the type of the crime that occurred. So date is just the date, time also as well. Place will be the geo-coordinates of the crime, and the typologies are according to some sort of classification that they have. And moreover, when these individuals involved in the crime are identified, there is some information regarding the offenders and the victims. So because of the relevance of this context, the unique data that is able to analyze, plus the usage of some of the cutting-edge methods in the causal analysis that probably you have known or you will see today at the keynote at the end of the day, this provides us with some novel causal analysis on the effects of these sweeps on crime. So mostly to give you more information about which is the policy intervention, first let me tell you that besides the relevance of Barcelona or crime globally, we have seen that there was an important increase on the criminal activity of gangs in the early 2000s in the city, mostly related to the Latin American migration pattern that took place in the early 2000s. So when we think about the gangs in this setting, we are talking about Latin gangs, mostly coming from Central America and South America. In 2012, the police identified around 2,500 members of these gangs in the metropolitan area, and as expected, or as they would portray, most of these individuals are young men that have some sort of Latin American origins. So either they migrated while young or they are just the first generation born in Barcelona or the area. In terms of policy, the public sector decided to tackle this problematic of gangs in 2 different ways and quite different. From the beginning of this problematic up until 2012, there was some sort of leniency approach or attempts to integration. So if you remember, as what just mentioned at the beginning of the presentation, the first approach was mostly related in this reducing the crime triggering disparities. So the first attempts were to legalize these gangs into local associations, trying to embed them in their community tissue, in their neighborhood, etc. And from the law point of view, the law was not punishing co-responsibility. So for instance, if some of us were a group and were involved in a homicide, only the individual who could have pulled the trigger or stabbed the individual would be the one being prosecuted, and the others would not be held responsible as well. However, the phenomenon continued to increase, and this approach didn't seem to be quite successful. So in 2012, there was actually quite a sharp policy change that moved towards the other set of strategies, so this tough on crime approach, and this is based in two things. The first one is by the creation of a specialized police unit, of an investigation unit that was based on sweeping gangs through a, let's say, criminal investigation that ended up in the sweep of the gang with the aim of dismantling them. And this was accompanied also by a stronger judiciary enforcement that was now having core responsibilities in terms of punishment and harsher penalties for gang members. On this, I must say that I'm not, since the two of them are kind of bundled, I will not be able to disentangle which part of my effects are related to one or to the other. I will take them as a compound. In terms of research design, this will be quite straightforward, the way that I analyze the effect of sweeps on crime. So here I will be following a staggered definitive approach, where my main outcomes of interest will be different criminal outcomes, meaning the probability of being arrested, the number of arrests globally, and how many of them were done in a group crime. Then I will have two different treatment arms, as I was outlining from the beginning of the presentation. Firstly, I'm interested in what happens to my first treatment group, which are the individuals arrested on the sweeps, but I will also have another treatment indicator that will relate to the peers of these individuals. I will just in the next slide clarify which are the peers, but for now you will think of individuals that are not arrested in the sweep, but are related to them. I will have a post indicator variable that will be taking values of one after a sweep. As any other definitive, my coefficients of interest will be beta 1 and beta 2 after controlling for individual and quarter fixed effects. And for this main baseline analysis of today, I will be focusing on my control units as all other individuals that are some sort of group offenders. So I will be excluding individuals that commit crimes by themselves. And just to clarify in this sense, for each offender or for each individual in my data set, I will have their longitudinal criminal data. So they have a unique identifier that allows me to track them over time. So I will be able to see how many crimes they commit over time. Then by doing this matching procedure that I will explain you now, I will be able to identify who is connected to whom in terms of criminality by matching the characteristics of their arrest. And taking into account also the layer related to the sweeps, I will be able to know who was arrested on a sweep. And with these three different sets of information is that I will construct my data. That now I will explain to you in quite a schematic and hopefully clear way. So first of all, we have all of these individuals that are the criminals, that are all the individuals that have been arrested during this 6-year period. For each of them, I have this unique ID for which I track them over time, knowing what they did in every quarter, and have some individual demographic characteristics. So this is the first layer of my data set. Secondly, through a matching procedure that I'm just doing is quite straightforward, by matching the registries of the arrest by the exact date, time, place, and the type of crime, I'm able to retrieve criminal networks. So just being clear, if I would be arrested with Mateo the exact same day, the exact same time, place, and for the same type of crime, I would assume that the two of us were involved. Once again, the richness of my data, for instance, allows me to exclude fights. I'm not, because in fights, I don't know if we are together or against. So this is something that in the data allows me to do so. And this is the way that I retrieve these criminal networks. Then I also have information regarding the sweeps that this new police unit did. So will be, for instance, the individuals inside of this red circle. These were the individuals that I identified that were arrested in a police sweep. And with this is that I construct my treatment arms. So in red, and quite straightforwardly, the individuals arrested are the ones that were arrested in the sweep. The second group of interest are the peers that are here, let's say the blue triangles, that are individuals that were not arrested in a sweep, but had a link with someone that did. And this link is prior to the sweeps. So they take place before any of the sweeps were taking place. The control groups are all other criminals that have some sort of link, and the gray ones will be the excluded, at least for the analysis that I will present today. So as you were seeing, this was quite a simple and schematic way to show you how the data works. And this is how it looks in reality, so how it looks in my data. The color schemes follows the one that I was telling you before. Overall, I'm able to identify 500 members of these 2,500 of the gangs in the metropolitan area. It's quite a decent coverage, but this relates to some operations outside the metropolitan area and other features. As expected, the, let's say, individual characteristics are quite as expected. Most of them come from Latin America. They are relatively young. A large set of them are males. And on average, they have, let's say, around 13 criminal peers. So this is how the data looks a bit in terms of descriptives. Let me show you which are the results of the effects of sweeps on crime for the two different treatment arms and for the different criminal activity variables. So here, what I wanted to highlight is just the percentages that the effects are significant. So the sweeps seem to have a negative effect on the criminality of both the arrested individuals and on their peers. In terms of the arrested individuals, these effects are almost 100% with comparison to the mean, whereas for the peers, it seems to be lower. But still, we have they achieve a reduction of around 26% in the peers in total crime. And when we take into account the gang as a whole, we see that these results imply that at the gang level, crime is reduced around 60% after the sweeps were taking place. In terms of event study exercises, let me show you the results on the left for the arrested and on the right for the peers. On the left, we see that for the arrested offenders, the effect is quite sharp and persistent over time, whereas in the for the peers, it only seems to be significant in the short term. So let's say 1.5 years after the sweeps were taking place, the negative effect of peers is no longer significant. So actually, the time patterns of one of the other are actually quite different. And now the question, or I think one of the most interesting questions, is actually trying to see what is behind these results or what is driving behind this. For the arrested individuals, it's not the most interesting one because, as expected, these individuals are in jail. So this is why there is a reduction in all types of crime, and this relates to this incapacitation effect of individuals being in prison, first awaiting trial, and then after the prosecution, that given that they are taking serious crime offenses, it's expected that they stay around 4 years a minimum in jail. Here, I'm not able to link this with the judiciary system, but this is what happens on average with the Spanish penal code. In terms of peers, I think it's something that is more interesting in terms of results. Here, for instance, we see when I analyze different types of crime, I see that there is no reduction in crime against property and that most of the reduction takes place in crimes against the person. How do I interpret this? Well, in the sense that these sweeps are not reducing, let's say, criminal human capital or crime production functions, because the crimes that are money-driven are not being affected. So rather, it will be just a loss of criminal environment or bad influences of these individuals taking place. Then I don't see any heterogeneous effects by age, by nationality, or even by criminal experience. And lastly, there is the other point, the last point regarding to peers that I want to make is that, well, there might be, how am I able to disentangle if actually these individuals are being less arrested or committing less crimes, right? There might be the two factors here. And since I see that the reduction on crime on peers is taking place on impulsive effects and that it persists over time, the evidence would be pointing more towards a deterrence effect in the sense that these individuals are being arrested actually less, rather than just being less caught or less detected than before, because these sort of impulsive crimes are harder to hide for a longer period of time. This is a bit also what's in line with the literature. And finally, the last point that I want to see regarding the sweeps is at the area. So I abstract for an individual analysis and I take into account municipalities, and I see that in the areas where the sweeps were taking place, no matter if offenders are arrested or not, there seems to be a reduction in damages to property and injuries, two different types of crime that actually are quite related to gang activity, and that the effects on welfare seem to be spilling out of crime to other welfare determinants, as there are some sort of insights of improvements in terms of high school educational outcomes, as well as health leading by emergency room entrance. So this is a bit what happens with the sweeps. And the last point that I want to make is regarding this counterfactual policy exercise. So as I was telling you before, we see that at the gang level, crime is reduced around 60% on average 1 year after the sweeps were taking place. But now the question that I'm trying to make is actually seeing if the sweeps could have achieved a larger reduction. So is this 60% good? Is it bad? Is there room for improvement? So on and so forth. So one way that I analyze this is actually comparing these results to ones that would have removed key players. Mateo mentioned some of these concepts in his presentation. Key player is just the individual that is the most central according to one measure, or we can discuss this afterwards, how to measure who the key player is, but it's kind of intuitive trying to say who is the one. So in order to do this exercise, I follow several steps that I will just briefly mention for the sake of time. Firstly, I will estimate peer effects on criminality according to the methodology proposed by Lee and co-authors in its latest paper. Here it addresses potential issues of refraction problems, network endogeneity, etc., by a three-stage least square procedure with a GMM estimator. Once I have this measure of the peer effects of criminality, I will be able to construct a centrality measure according to Ballester and Zenou. So this measure not only takes into account network, but also contextual effects. So it's actually quite of a rich measure. And once I construct a centrality measure for each individual in each gang, I'm able to rank them. So inside each gang, I will be able to rank individuals according to the centrality. With this, identify the key player or the number one key player according to the literature, but also sort all others. And this is actually quite important because when the previous literature has analyzed which is the effect of reducing the key player or removing the key player, they only take into account when they remove the top one individual, the key player. However, this is not a benchmark to compare sweeps because these are large-scale interventions. They go after a broader set of individuals of the gang. And because of this, I construct, let's say, this cumulative measure or this predicted reduction in criminality as a function of the number of key players removed. So it takes into account the previous literature by removing the first key player, but it will also construct a cumulative measure of taking the second one and the third and so on and so forth as a number of the number of key players removed. And with this is that I will make my policy comparison, which is in the last graph that I'm showing you here. So when we have this blue continuous line that is increasing is the prediction of the model of how much crime would have been deterred as a number of the key players being removed. As expected is increasing, so the more individuals I remove, the higher the reduction in criminality. But again, as expected, let's say, each individual has a lower contribution to the reduction in criminality. So this function looks very much as we should expect according to the intuition behind it. And the other point that I want to highlight here are the two dashed lines that show the average coordinate of one of the sweeps of this police unit. So on average, here I'm showing you the average because of sensitivity reasons of the data, but we know that on average, these gang sweeps were arresting 60%, as I was telling you before, and taking on average around 18 individuals. How do I read this graph? Well, I say that the sweeps could have actually achieved a larger crime reduction if key players are removed. So for instance, we could have achieved the same 60% reduction in criminality by taking fewer yet more central individuals, or by targeting better the 18 individuals, we could have achieved a reduction in criminality of around 95, 96%. So actually, by knowing which is the network structure behind the gang and by identifying key players, we could improve the design of police sweeps. This is the last that I had to show you today, but just to give some concluding remarks, we have seen in this presentation that gang sweep interventions can achieve significant reductions, not only in the individuals arrested, but also quite relevantly on their peers, particularly when we take a look in crimes against the person, and that these effects might also spill over into some other welfare determinants as health or education, as I briefly outlined. However, another point that this presentation showed is that by understanding which is the network structure of gangs and by identifying key players, we could achieve larger crime reductions, at least in comparison in this setting. On this, I must say, however, that there are some, let's say, assumptions of the model that we have to take into account. For instance, we need to consider which are the costs in terms of information of identifying key players, that this might be quite costly. And the other secondly, that this model assumes that there are no network rewiring, so that once key players are removed, all other individuals do not connect once again, and this is kind of a strong limitation. And actually, the other point that I want to make is actually that the police should identify if it's actually feasible to go after key players, or they might be also too costly in terms of police resources. So these are things that we should take into account when designing, let's say, key player targeting strategies. But however, all in all, this paper provides a contribution kind of relevance into the public agenda when we are now seeing that police fundings and police interventions are being kind of discussed and reviewed. And from a broader point of view, even we have to set the discussion of how these hard policies and some other behavioral and soft policies should be combined and coordinated, let's say, into a unified framework to fight crime. This is what I had to show you today. So thank you for your time. I'm hoping, I think I'm right on time, but still, thank you for being here. I think that with this, we will finish the part of presentations of this session. But now let's move into some sort of Q&A if you wish. So firstly, let's continue with the presentation structure and let's see if there are questions for Mateo in the audience. If you have them, please raise your hand or just go ahead and ask. Well, I do have questions, Mateo. If there are no other questions from the audience, I do have many questions. I like your presentation. I like how easy it was to understand for non-theoreticals like me. So thank you for showing this in such a clear way. I maybe had two different questions that I wanted to ask. Firstly was that, would it be possible in your model to have some sort of mixed strategy? So at the first you were saying that individuals are either fully working or completely criminal, and we have seen in real life, let's say, that sometimes it works half and half and so on and so forth. So my first question was trying to see if your model could cater for some sort of mixed strategy. And the second point was mostly related to policy. You showed us the simulation through different, let's say, model characteristics. So the P, this alpha, this eta. And I think it would be nice to have, as you were saying at the end of your presentation, saying some sort of policy thing, in the sense that, could you tell from your model if the policy, which of these parameters should be targeted for a better policy design or for a higher reduction in criminality? These are the questions that I have. So thank you.
Oh, no, thank you very much. Those are, very insightful questions. The first one, in terms of mixed strategies, yeah, for sure. It would be possible to look at not only pure strategy in Nash equilibria, but also mixed strategy in Nash equilibria. It would be, way harder in the sense that you saw that, if we limit ourselves to only pure strategies, you get way more equilibria than agents, just by the combinatorial kind of nature of the game. I'm not sure if methods have been developed to find all the mixed strategy equilibrium in those particular games, but that's something that we could explore. It's a route that we haven't decided to take just because I find it hard to interpret, right? I'm more comfortable saying, there's two different equilibria, one in which this person is a criminal, one in which they aren't, than in maybe saying, there's this equilibrium in which he kind of randomizes. It's the interpretation would be maybe harder, but yeah, maybe in the future, after we're done with this first pass. Then in terms of policy recommendations, yeah, it's a part of the paper that we haven't delved into too much. It's kind of hard because of the whole multiplicity issue. So, for instance, it's hard to say, who would reduce the crime most if I don't know which of the equilibrium will be played. But we're certainly, for instance, one thing that we do in the paper is, for instance, characterize what are the conditions that are necessary for an equilibrium with zero crime to exist. And that's something that, for instance, a policymaker could be interested in doing, like saying, I don't know how this community is going to evolve, but just let me make sure that the equilibria that could be hosted by that community are just as nice as I can. So one thing would be, make sure that you offer possibilities for people to have, very high wages so that they disrupt the social propagation of crime. That would be effective. Second, focus especially on if you see a very polarized network in which there's very influential people, try to make sure that that influential person is lawful. That kind of thing, I think, would be sensible. But yeah, it's something that we could definitely emphasize in the paper. Thank you so much. You're muted.
I clicked, but it didn't work. But thank you. Are there any other questions for Mateo? Well, if not, let's move. I will then read the paper and might send you more questions and things.
Thank you.
Thank
yeah,
you.
Thank you so much.
Then we might move to, let's say, a second block of questions for Camilo, if there are some from the audience as well.
Well, I do have one, and I'm very unfamiliar with this synthetic controls literature for a while. I haven't seen it, its evolution, and I'm very interested in the factor aspect of how you control for this non-parallel trends. But could you say maybe a bit more of how do you go about deciding how many factors are going to go in? Where do they come from? How do you end up selecting them? And then I think it would be interesting if, for instance, you could show them the estimates that you get. I know that often they don't have an interpretation, but if you could match, like, for instance, hey, this factor looks like it is related to states that are more, municipalities that are more susceptible to drug crimes. If you could show that those things that you do not impose a structure on end up like representing things that are interpretable, that would be like very appealing.
Okay, yes, that is a very important question. And well, we do have many graphs of the factors and the factor loadings. But as you say, they are often very hard to give a concrete interpretation to them because they are linear projections of the real underlying process. But sometimes we do find some interpretable results. But in our case, for example, the time factor capture some national trends on the reduction in the use of pretrial detention that started well before the reform in the 2000s that coincide with the democratization process in Mexico. So it does give some interesting results that more often than not, if you don't have, because our problem is very complex, so if you have a very simple and well outlined problem, I think you will get those interpretable factors, but I think they are very important in the robust checks and I can go too deep explain the technique, but it's very important for the factor loadings to have a common support, because there could be an omitted variable bias, if that could be a sign of an omitted variable bias.
Right.
Thank you for your question, Mateo.
If I may, I do have a couple of questions as well. So first, I wanted to ask you if you showed us a bit of the size of these effects, but how these compare to the mean? Can you say us in terms of percentage, or how these compare to, let's say, other changes? Are these large effects? Are they big? So giving a bit of more context in this might also tell a bit of the results that you were saying. And then I have a different question regarding to the very beginning of your presentation, that you showed how this reform changed many potential factors, so deterrence, etc. So is there any way that you could disentangle which of these are actually being mostly affected and driving your results? So for some crime categories, you know that these results are not taking place, so you can say that this is fully driven by one of these features, or something on that line that will help us understand what is driving these results.
Yes. Well, for the size of the effect, it is, if you compare it to the effect of the drug war, it was not very big. Dell has an estimation of this effect that she relates to the hard on drugs policy of Calderon, and the effect of that policy was around 24 or something like that, and that is crazy big. It's very big. 4 is also big, but we have to take in mind that those are municipal level homicide rates, and those rates are very noisy, because in a year there are many years with no dead persons, and some years there are 20. So therefore, there is a huge variance in municipalities. But if we were to interpret this rate as a country, that would be also very high. The murder rate of 4 per 100,000 is the murder rate of United States. And if the effect of this policy is to have 4 more dead persons, that is a quite big effect. But we should be very cautious with this, careful with this interpretation, because, as I said, municipal homicide rates are not that easily comparable with national homicide rates. And I forgot your second question. Sorry, Magdalena.
If you have some sort of way of disentangling which of the many factors that you showed at the beginning can be driving your results.
Yes, well, that is very difficult to do, because the reform came in place as a whole package. So we can really disentangle. We tried, but it's very difficult to disentangle the effect of, the probability of punishment, celerity of justice, and so on. But in the paper we could, and we did, study the interaction between the punishment rate, how many people are punished for every crime, and organized crime, because we were trying to explain the mechanism why the procedural reform had a positive effect only on the subsample of municipalities that had an establishment and established a cartel presence. And our hypothesis is that it was very hard for those municipalities to adapt to the new rules of the system and tackle an unprecedented crime crisis at the same time. So I hope that answered your question, and thank you for the question.
Thank you. I think that we are a bit tight on time, but if anyone wants to ask me some questions, no, yeah, happy to hear.
Yeah, I had some. I have so I have three. I'll pass them now. So the first is when I was trying to work with empirical data on networks, a frustration of mine was how to handle the fact that the network might be dynamic, and you know how to incorporate that into the analysis. You know, at what point to take the snapshot of the network that gets incorporated. So maybe if you could say a little bit more of, you know, what's your time horizon, or what did you do about that, and what gives you confidence that it might be stable. The second one is if you could say a bit more, like it seems like the policy change is quite you know, big, and just want to know a bit more of, you know, what caused that shift in the stance of on crime, and if that maybe generates any kind of threat to your results. And the third is I haven't done this type of methods for a while, but the outcomes that you're measuring seem like persistent over time. So for instance, total crime, which kind of counts with respect to the previous year. And I was wondering if that kind of correlation is in some way problematic to your empirical results. That's right.
Thank you. I will go a bit briefly on them and different order. What caused the policy change? That crime didn't respond to the previous change, and actually was triggered by a homicide of a teenage boy in a high school that got in the middle of a gunfight, and he was completely innocent, got in the middle. Media went madly because of this, and I do check that there are no other changes in police resources. There are no new hirings, no patrolling, so these things do not seem to change. And this is something that is reassuring, as you were saying, because it doesn't pose any threat. Then in terms of the correlation of the results, I do allow for some, the networks, the error structure that I allow with this Driscoll gray allows to some sort of heterogeneity and possible serial correlation across error terms. So this is some way covered that you were mentioning as well. And then the last point, and the most tricky one, I think it relates to what you were saying about dynamic networks, right? So in this case, since I was analyzing a disruption in the network, I will take a photo just before the disruption was taking place. But I do agree with you that it's something that is still not solved in the literature regarding networks. I recently read a review of how to deal with these features. So if you're interested, it's kind of a short review by Bramouillet, and it's really short and really insightful on this. And actually, when you have repeated networks, or when you have a panel of networks, it's easier to solve other potential issues regarding network bias, for instance. And I think that what I've heard from previous comments is that the network literature might go into this, into the how to get more insights into the dynamic frame of this. So yeah, thank you.
Great, thank you.
I have a question, but well, I don't know much about networks of crime, but this may be a very simple question. But you were saying that you couldn't account for the rewiring of the network. I don't know if you could elaborate a bit more on that. because intuitively, I think that could be a very important factor if we study crime gangs and if we're dealing with a sort of crime that has a more complex or structure, let's say.
Yes. So what I was mentioning is that the literature to identify key players assumes that there is no network rewiring. So this is the limitation, not for the analysis, but for the identification of who is the key player. So this is kind of the limitation of that, let's say, strategy. But I do agree, and it quite relates to Mateo's question, that how networks change and rewire and move on from a dynamic perspective after some sort of disruptive event is something that is really relevant and understudied in the literature. So I haven't done it so far, but it's something that I might explore in the future. Yes, once I also have a longer time frame. So as my span is a bit short, if I gain further observations after the switch for taking place, I would be able to tackle this in a more robust way. But yeah, thanks.
Thank you, Magdalena.
So I think that if there are no other questions, we can wrap up this session. We thank the presenters as well as the audience, and apologies for the late finish, but we started a bit late as well. We have a break now, and we continue for keynote speakers in 25 minutes. So that's it for us. Thank you for being here today. I'll see you and talk to you. Bye.
Thanks.
Bye.